Let's correct worksheet 1.2. So activity 1 says, consider the following depiction of an atom. What is the atomic number? All right, so remember, the atomic number is the number of protons in the nucleus, okay? Protons that are also represented like P plus, like this. So the number of protons in the nucleus, if I count them, I have 1, 2, 3. Sorry, this was not a proton. So the positive charged particles. So 1, 2, 3, 4, 5, 6. So we have 6 protons, 6 positively charged particles. So the number of protons, the atomic number, that is Z, equals 6. What is the mass number? So the mass number is going to be the number of particles in the nucleus. So it's the number of neutrons plus number of protons all together in the nucleus. So if I count all the particles that I have in the nucleus in this picture, I will understand that the mass number, which is A, equals to 12. Because altogether I have 12 protons plus neutrons. So I have 6 protons and 6 neutrons, actually. Now, write the nuclear symbol for this atom. So the nuclear symbol for the atom, it's the carbon, like this, okay? That is the symbol. It's the carbon because I know that the atomic number is 6. And if I go to the periodic table is going to have the element that has 6 as its atomic number is carbon. So for the nuclear symbol, I'm going to write carbon. And then at the bottom, we're going to write the atomic number. At the top, we're going to write the mass number. And that's the nuclear symbol for carbon. Again, I know it's carbon because the periodic table shows me how the element that has 6 as the atomic number is carbon. So you need the periodic table to do this. Next problem. Examine the table to the right and answer the following questions. So I'm going to scroll up. How many isotopes of magnesium occur naturally on Earth? I just need to go to the table and I say that I have 1, 2, and 3 isotopes of magnesium. So the answer here is 3. As simple as that. The next one. Describe what all isotopes of magnesium have in common and also how they're different. So I need to actually look at the isotopes of magnesium. What do they have in common? Okay, so what they have in common is the atomic number. The atomic number is 12 for all of them. That means that they have the same number of protons. Okay? So that's what is in the same for all of this. Well, because all of them are magnesium. And what is different from them? So what's different? What's different, as you can tell over here, is their mass number. So what's different is A, the mass number. And that means that they have different number of neutrons. That is what makes them different. That is what makes them be isotopes. Okay, so now it says, if you select one carbon atom at random, so now instead of magnesium, we're going to focus on carbon. Okay, so if you select one carbon atom at random, I have carbon here and another isotope of carbon here, okay? The mass of that atom is most likely to be, well, if you actually look at the abundance in nature of the carbon, you see how carbon 12, this one over here, has an abundance of 98%. And carbon 13, this one over here, has an abundance of 1.1%. So if I actually get a sample of 100 carbon atoms and I pick one, most likely, I'm going to pick this carbon atom, right? Because its abundance is way, way, way higher. So that's why the mass that is the most likely to be, it's going to be the one of the carbon 12. So 12 AMUs. Okay. What is the mass in AMUs of 100 C12 atoms? So this is easier than what you think. So the C12 is this one over here, the one up on top. If I have 1, its mass is going to be 12. But if I have 100, it's just going to be 100 times that mass. So the answer is going to be 1200. And what about the other one? So the other one is the carbon 13. If I have one carbon 13, its mass is 13.0034. But if I have 100 of those, the mass of the carbon 13, it's going to be, all those 100 atoms, is going to be 1300.34 AMUs. That's the unit. And finally, if you select 100 carbon atoms at random, the total mass will be, and you need to choose an answer, right? So the answer here, it's going to be that it's going to be slightly more than 1200 AMUs. And here is the thing. Remember, we said before that the abundance of the carbon-12 atom is 98.89%. So the mass of the carbon atoms is going to be 12. But the thing is that we still have 1% of those carbon atoms that are the other type of isotope. So that's why, because the mass is a little higher than that, that's why we say that it's going to be slightly more than 1200 AMUs. So if I have 100 carbon atoms at random, 98% are going to have a mass of 12, and 1% is going to have a mass of 13. So altogether from those 100, more or less the mass is going to be a little higher or slightly more than 1200. That 1.1% contributes to being a little higher. So next problem. They give you the nuclear symbol of these atoms, or in this case some of them are ions, and you just need to find out how many electrons, protons, and neutrons they have. So we're going to start with the magnesium. Magnesium over here has no charge. You see that, right? So you are going to first look at I always do, to the atomic number, that is 12. And that 12 is going to tell you the number of protons. So you write 12 protons here. Now, the mass number, 24, is going to be the number, 24 is going to be the number of protons plus the number of neutrons. So if 24 is the total, okay, and I know that the number of protons is 12, so 24 minus 12 is going to give me the number of neutrons, right? So the number of neutrons in this case is going to be 12. Now, the electrons, because this isotope has no charge, when it has no charge, having no charge means that the number of protons equals the number of electrons. That's why it has no charge, because the negative and the positive charges are balanced. So the number of electrons in this case has to be the same number as the protons. So it's going to be 12. Next one, sodium. I'm going to erase this so I can do the next one. So sodium, in this case, you see that it's sodium plus. It's an actual ion. So because it's an ion, the number of electrons is going to be different from the protons. You will see. But let's start doing the same thing. The first thing is that we're going to look at the atomic number. That is 11. 11 protons. So we have 11 protons, and then to find the number of neutrons, you take the mass number, 23, and you do that minus the number of protons, that is 11. It's going to give you the number of neutrons. So it's again 12. And then finally, because we have an ion here with a positive charge, having a positive charge means that this atom has one less electron than the neutral, okay? One less electron, because it has one positive charge, it has one less electrons than the neutral atom. The neutral atom would have 12, so this one has to have then 11. And again, it's because it has one less electron. That's why it has a positive charge. It loses one negative charge and gets positively charged. So one positive charge means that the atom has, or the ion has, one less electron than protons. Next one is the chlorine, in this case chloride, because the chloride is the ion. So for the chloride, again, we start with the atomic number. That's going to give us 17. That's going to be the number of protons. The mass number, 35, is going to give us the number of neutrons, because you do 35 minus 17, which is the number of protons. That's going to tell you what the number of neutrons are. And the number of neutrons in this case is going to be 18. So number of neutrons, 18. And finally, because chlorine is an ion, it has a negative charge. One negative charge means one more electron than the neutral chlorine. The neutral chlorine would have 17 electrons, same as the protons, but the chlorine minus has one negative charge extra. So it has one extra electron. So therefore, instead of 17, it's going to be 18 electrons. The next one would be the nitrogen. So the nitrogen has 3 negative as the charge, okay? And we do exactly the same thing. Let me just use another color. So the nitrogen has 7 as the atomic number, therefore 7 is the number of protons. And then to find the number of neutrons, we take the mass number, 15, minus the atomic number, 7. That gives us the number of neutrons. So the number of neutrons in this case is going to be 8. So 8 is the number of neutrons. And finally, because nitrogen has a 3 minus as the charge, that means that 3 minus means that it has 3 more electrons than the neutral atom. So if it has 3 more electrons, the neutral atom would have 7 electrons. So this one is going to have 10 electrons. 3 extra negative charges. And finally, we're going to do the last one with aluminum here. So with aluminum, let me use a different color. Here, aluminum has an atomic number of 13 protons. To find the number of neutrons, you take the mass number, 27, minus the atomic number, which is the number of protons, which is 13. And the answer is 14. So it's going to be 14 neutrons. And finally, aluminum 3 plus has 3 positive charges. That means that it lost, not gained, it lost 3 electrons. So it's going to have 3 less electrons than the neutral atom. So therefore, instead of 13 electrons, it's going to have 10 electrons. This one problem is asking us to find the average atomic mass of lithium if 7.42% exists as lithium-6 with the mass of 6.015 AMUs and 92.58% exists as lithium-7 with a mass of 7.016 AMUs. So in order to do this, to find the average mass, I'm going to write here mass average. You need to find, or you need to remember the formula that we learned the other day that says that the average mass is going to be the abundance of each of the isotopes divided by 100. So in this case, the abundance of lithium-6, 7.42 divided by 100 times the mass of the isotope. So times 6.015 plus the abundance of the other isotope, so 92.58 divided by 100 times the mass of the other isotope, which is lithium-7, and the mass is 7.016. You go ahead, plug these numbers in the calculator, and the answer is going to be 6.94 AMUs. So again, you do the abundance over 100 times the mass plus the abundance over 100 times the mass. The next problem says magnesium has 3 naturally occurring isotopes. 78.70% of magnesium atoms exist as magnesium-24 with its mass. 10% exists as magnesium-25 with its mass, and 11.17% exists as magnesium-26 with its mass. What's the average atomic mass of magnesium? This is the same exact thing we did before. So here we are going to do the same thing. To find the average mass of an isotope or the isotopes of an element, mass average, and then you have to multiply the abundance, 78.70 divided by 100 times the mass of the isotope. So the mass of the isotope is going to be 23.9850 plus the abundance of the following isotope, 10.03 over 100 times the mass of that isotope, so 24.9858 plus the abundance of the isotope, the third isotope. So let me change the color now because it's the third isotope. So the abundance of the third isotope, 11.17 over 100 times the mass of that isotope, 25.9826. You calculate that, and the answer is going to be more or less 24.31. Now, if you have a problem where they don't give you the masses of each of the isotopes, then as the mass, you would use the mass number. Okay, this is not the case though. All right, so now we're gonna go to solve some problems, or we're gonna solve some problems on radioactive decay. So you just need to write the nuclear equations here of each of these for each of these radioactive isotopes, the nuclear equations. So this is how you do it, and it's all the time the same thing. You get the radioactive isotope, so that would be the isotope that is decaying, that is being decomposed. Its nucleus is being decomposed. So the carbon 11, 6 yields or forms, it's telling you a positron. So a positron is 0, 1, E. You need to know the symbols of each of the particles or each of the radioactive decay types that we've learned. All right, so now you need to go to the periodic table, and on the periodic table, you need to find the element that has an atomic mass that plus 1 equals 6. So that has to be 5, right? So 5 plus 1 equals 6. And then that element is going to be B, boron. And then now, for the mass number, you know that it has to be, the boron has to have a mass number that plus 0 equals 11. So it's going to be 11 plus 0 equals 11. Next one. Let's change the colors here. So the next one, it's the bismuth. And then you have 214, 83. And this produces as well a positron, so plus 0, 1, E. So again, you need to find the atomic mass that plus 1 equals 83. That's going to be, hey, my bad. In this case, it's a beta particle. It's not a positron. So this one is negative, okay? So what number plus negative 1 equals 83? 84. So now I go to the periodic table, and I find that polonium has an atomic number of 84. So now I have to find its mass number. So what number plus 0 is 214? 214. Next one. Let's change the colors. So I have Neptunium over here, and P, and it's 237 is the mass number, 93 is the atomic number, and it's releasing an alpha particle. So yields, and then the alpha particle is 4, 2 helium. All right, so what atomic number plus 2 equals 93? 91. I go ahead and go to the periodic table, and I see that palladium, Pa, is going to be that element that has an atomic number of 91. What mass number plus 4 equals 237? 233. So that's it. Next one. Iron. So you have the iron here with a mass number of 55, and 26 is the atomic number. Okay, so here this yields and produces a positron. So you put the 0, 1, E. Okay, so now what atomic number plus 1 equals 26? 25. I go to the periodic table and I find the element that has 25 as the atomic number, and that's going to be Mn, manganese. So now, what mass number plus 0 equals 55? 55. So 55 is going to be the mass number for manganese. Next one. We have radium here, and then 226 and 88. So this produces an alpha particle. So 4, 2 helium. Now, what number plus 2 equals 88? 86. 86 plus 2, 88. So 86, I go to the periodic table and find the element that has 86 as the atomic number, and that's going to be radium. So now, I look at the mass number. What mass number plus 4 equals to 26? 222. And finally, we have lead here with a mass number of 214 and atomic number of 82 that forms a beta particle, which is a negative electron. It's an electron. Okay, so what number plus negative 1 equals 82? 83. I go to the periodic table, I find the element that has 83 as the atomic number, that's bismuth. And then the mass number plus 0, 214, so 214 stays the same. And that's how you do nuclear equations. Let's continue with radioactivity and radioactive decay. So, in this problem, I don't know why the arrows are not showing up, but it doesn't matter. We have an arrow here. 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 And that's it. Okay. So, in this problem, you just need to complete the nuclear equations with the information, or nuclear equations or nuclear reactions with the information that they're giving you. So in the first case, you have the gold that is turning into platinum, and you see how the mass number and the atomic number are something to analyze. So now, how do I analyze this? What I'm going to look at is the atomic number. Why? Because I see that the atomic number is changing. It's going from 79 to 78. So what number plus 78 equals 79? 1. What number plus 195 equals 195? 0. So what's the particle that has 1 and 0? The beta particle, but beta positive, which is the positron. Next one, we have potassium here, and we see how the atomic number has changed to argon's atomic number. So again, I have a 1 here, and then I see that the mass number hasn't changed from 38 to 38, so it's 0 here. So again, I have a positron. It's a 10E, so it's a positive electron. Now, the next one, I see how 86 has gone down to 84, so I needed 2 on the particle that it's been emitted as the atomic number, because 2 plus 84 equals 86. And then I need, up here, I see that the mass number is going from 222 to 218. So I need a 4 up here, because 4 plus 218 equals 222. So what is the particle that has 4 as the mass number and 2 as the atomic number? The helium, which is the alpha particles. Next one. Now we have to find the transmutation. So they give you the oxygen, 15. And you see how for the oxygen, the atomic number is 8. And then we have a beta positive particle here, a positron here. So 1 plus 7 equals 8. Okay? And then 0 plus 15 equals 15. So I go to the periodic table, I find the element that has 7 as the atomic number, and that's going to be nitrogen. Next one. This is a 15 here, because that's a 15. Okay, so next one. What's the element that originally transmutated to turn into mercury and release an alpha particle? So this is how we do this. We take 80 plus 2, 82. And then 4 plus 200, 204. I go to the periodic table, I look at the atomic number of 82, and I see that that's going to be lead. And finally, iodine, it's releasing a beta particle. And then what's going to happen is that 54 plus negative 1, it's 53. And then 112 plus 0 is 112. And this is going to be xenon. For the last activity here, you need to complete this radioactive decay series. And what you need to do is, you're given initially the uranium-238. That's your initial. I'm going to start from here, okay? And I'm going to just show you what you need to do for a few examples. So you take the uranium-238, and remember, uranium-238. 238 is the mass number. If you actually look up on the periodic table, uranium has an atomic number of 92, okay? So, uranium-238, which is this isotope over here, releases an alpha particle, this one here. So an alpha particle, remember, is a 4-2 helium nucleus. So what you need to find out is what comes next. So what comes next, in this case, is done, but I'm going to show you why is thorium. Okay? So what you need to do is what we have been doing before. You say, okay, what number plus 2 equals 92? So 90 is going to be the atomic number. Now you go to the periodic table and you find the element that has 90 as its atomic number. And the element that has 90 as its atomic number is thorium, TH. TH. So you write TH. That's why this is going to be the next one. And then what's going to be the mass number? Well, what number plus 4 equals 238? What number plus 4 equals 238? 234. So that's why 234 is going to be the mass number of the thorium. And that's the same thing that you need to do for the rest of the process. I'm going to do one or two more examples, okay? The next one is telling you that you have thorium. So now we start from here. So thorium, that is 90. That's the atomic number of thorium. We find that on the periodic table. And it has a mass. It has a mass of 234. So this is releasing a beta particle. So a beta particle, careful with that, it's a negative electron, okay? So it's a 0, -1 e. So you need to find the new element, the transmutation. So the new element, it's going to be an element that plus minus 1 has an atomic number of 90. So that's going to be 91. That's going to be 91. 91 plus minus 1 equals 90. I go to the periodic table and I find the element that has the 91 as the atomic number. And that's going to be protactinium. Okay, so Pa. Now, what is the mass here? That's the mass number. So that number plus 0 equals 234. So 234. So there we go. This element over here is the one that you see here. Now we go to the next level. So the next level would be the Pa 234 91 releases a beta particle. So 0 minus 1 e. So to find, this is minus 1. So to find the new element, you have to find an element that has an atomic number that plus minus 1 equals 91. So that's going to be 92. So 92 plus minus 1 equals 91. And then mass number plus 0, 234. So 234. So I go to the periodic table and I find the element that has a mass, an atomic number of 92. And that's uranium. And this over here is this. And so on. Okay? So for the rest of them, I'm going to just complete the answers. And if you have any questions, you can absolutely ask me all the questions you want. The uranium-234 after releasing an alpha particle, it's going to form the thorium-230. This one will have to release an alpha particle that is going to be a 4-2 helium nucleus to find the radium, to form, the radium. Now, this one is going to release another alpha particle to transmutate. Then, another alpha particle has to be released to get polonium. The polonium is going to release, it's already here, an alpha particle to helium, that's an alpha particle, to form the lead-214. The lead-214 is going to release a beta particle, so 0 minus 1 e. That's a beta particle to form the bismuth. The bismuth is going to release another beta particle, 0 minus 1 e, to form the polonium. The polonium is going to release an alpha particle, so 4-2 helium. That's what it's going to release to form the lead-210. The lead-210 is going to release a beta particle to form the bismuth. The bismuth is going to release a beta particle, 0 minus 1 e, to form the polonium. And the polonium finally is going to release a 4-2 helium, that's an alpha particle to form lead-206. And this is stable, so that's why we're done with the series.